All right, now that we understand the basic nature of reactions and reaction rates, we're going to talk about factors that affect the reaction rate. First off, reaction rates are all about collisions. Okay, so in order for a reaction to take place, the first thing that has to happen is you have to have a collision. Okay, so you have to have molecules that collide. Now, in that collision, they have to collide and they have to be facing the right direction. Okay, you have to have atoms in the right place for the bonds to break and reform. So they got to collide, they got to face the right direction, and the last thing is they need to have enough energy. So they got to collide, they got to face the right direction, they got to have enough energy. If these three things don't happen, then what could possibly happen is they could collide, but if they're not facing the right way, they'll just bump off each other and keep moving. They could collide even facing the right way, but with too little energy, they're not moving fast enough, they're not hot enough, then they aren't going to be able to react and make a product. So what I want you to think about is a way that we can increase the rate would be by increasing the number of collisions. If more reactants are present, more of them will collide and successfully make more products. So more of them happen over the same period of time, that means I have a higher rate. Okay, more collisions over the same time is a higher rate. So I want you to think of this. If you have steel wool, you can ignite steel wool and the iron is going to burn in air. And you have this kind of sparking, little kind of dazzling reaction. But this happens in regular air. And regular air is actually around 70% nitrogen gas, which isn't a part of this reaction. So less than 30% of the actual air around this is the oxygen being used in the reaction. If we were to instead do the same reaction but put it in pure oxygen, we get this rapid, explosive, very exothermic reaction. It's the same reaction that's taking place, it's just that it happens with a lot more of the reactants present, so it happens a lot more quickly. We have a faster rate. Now, if the molecules are moving faster, okay, aka a higher kinetic energy, a higher temperature, more of them are going to collide and successfully make products. Okay, what ends up happening here is if the average energy is higher, you're saying that a higher percentage, a higher majority of those molecules are going to have enough energy to make a product. So that is going to increase the rate as well. So the rate goes up if the concentration goes up. The rate goes up if the temperature goes up. Next, if gaseous reactants are put under more pressure, more of them will collide and successfully make products. So the thing that we have to be thinking of here is if, let's say I've got a container, and in this container I have several gas particles, okay? But, you know, gases are relatively spread out. As long as they're far from each other, they're moving fast, they will collide, but a way that we can increase the number of those collisions would be to go ahead and decrease the volume of the container. This causes more pressure, they're closer together, which means they have more collisions with each other, and more collisions is going to result in making more products. Okay, so increasing the pressure of gaseous reactants is going to increase the reaction rate as well. Now, last concept here is we have to understand if a catalyst is introduced. A catalyst, more of the reactants are going to have enough energy to make the products when they collide. So this is a little bit different. Whereas all of the previous examples increase the collisions, here we have the same number of collisions. The only thing that's different is the energy that's required to make reactions take place. Remember before we said they've got to collide, they've got to be facing the right way, and they have to have the right amount of energy. Well, what we're doing is we're saying previously, let's say the energy was, I'm just going to say I needed 1,000 energy units. Okay, and if I have 10,000 collisions, let's say only 10 of these are greater than or equal to 1,000 energies. Okay, I know I'm not using actual units, but this is just to hopefully get you to understand the basic concept. So 10,000 collisions happen. Only 10 of them have above 1,000 energy. But by adding a catalyst, I can make this 1,000 number, this required, let's say I reduce that to 500. Well, in 10,000 collisions, only 10 were greater than 1,000, but let's say 100 of them are greater than 500 energy. What this means for us is that 10 times as many reactions will take place, even though the same number of collisions happen, 10 times as many reactions are going to be successful. So a catalyst is going to increase the reaction rate by decreasing the energy requirement. Now, for these practice problems, I will let you pause now. Assume that you've done that, and we will continue. If more successful collisions happen in the same period of time, this results in an increase in the reaction rate. More collisions, same time. To speed up a reaction, we could blank the temperature. So speed up, I want to increase rate, so I should increase temp. So we would increase the temperature. To slow down a reaction, so I want to decrease the rate, slow down a reaction, you would do what to the pressure? So less rate would mean less pressure. I should decrease the pressure. How does a catalyst affect the energy of collisions? A catalyst lowers or reduces the activation energy, the energy requirement. A catalyst will blank the rate of reaction because of the blank activation energy. So perfectly tied in with this question, right? A catalyst will increase the reaction rate because of the lower or reduced activation energy. Adding more reactants to a reaction chamber will cause a blank in the reaction rate. So more reactants, what this is telling you is that we are increasing the concentration of the reactants, and you'll recall that an increase of concentration results in an increase in the rate, so this will cause an increase in the reaction rate.